arithmetic and geometric sequences. An arithmetic sequence, and this is just a basic introduction, an arithmetic sequence is one that you're just adding the same number each time. Like if I did 8, 10, 12, 14, that's an arithmetic sequence with a difference of 2. I could even have a negative difference. Let's say I did 14, 11, 8, 5. It's still arithmetic, but my difference, since I'm going down, is -3. Geometric. You're multiplying by the same number every time. So you could have something like 4, 16, 64 to 56. So notice how this time I'm multiplying everything by 4, and with geometric it's called a ratio. D, arithmetic, is called difference. Ratio of 4. Let's say I did this. 2, -6, 12, -36. Oh, wait. Sorry about that. Well, let me just... 2, -6, +18, -54. That's what I get for making these up. This one, notice how the signs are alternating, so that means your ratio is going to be negative, and what you're multiplying every time? 3. Now, what about if it's something like this? Let's say 64, 32, 16, 8. Notice how what I'm doing this time. I'm getting smaller, and it's actually dividing by 2, so my ratio is 1/2. Now, the good thing about geometric, if you want to know the ratio, all you have to do is put the second over the first, 1/2, or the third over the second. Just like even this one. Second over previous term or first term, -3. 18 over -6. So if you're unsure of what the ratio is and you know it's a geometric sequence, you can always do the term over the previous term and reduce, even if it was something weird, like let's say x squared y cubed, x to the 4th, y to the 7th, x to the 6th, y to the 11th, and you were unsure. Notice how if you put the second over the first and then reduce, your ratio was just x squared y to the 4th. I know it's a little unique one, but I'm just saying it works for all of them. Now, just to tell you about a couple, since this one was kind of short, we'll get to the formulas next on the next video. But let's say there's some special kind of series, while we have a second to mention them. A Fibonacci sequence. Now, a Fibonacci sequence, a true Fibonacci sequence, starts with 1 and 1, and then you add those terms to get 2. Add those terms to get 3. 5, 8, 13, and so forth. That is a true Fibonacci sequence. Now, you can have a modified Fibonacci sequence. Let's just say I gave you this and I said create a Fibonacci sequence. Well, 4 and 7, 11, 7 and 11, 18, 29, so forth, because you're just adding the previous 2 terms. We'll get into a little bit more on that with recursive formulas and that sort of thing, which is what the next video will be. There's also one more, since I have just a minute, since this one is kind of short. Harmonic sequences. Harmonic sequences are arithmetic sequences, but they're under ones. So like if I had 1/2, 1/6, 1/9, 1/12, notice how I did it again, didn't I? Let's just change that to 3 to make it easier. Sorry about that. I'm just off tonight. Notice how you added 3 every time. So that would be a harmonic sequence. Even if you had something like, we'll do one more, 1/5, 1/17, 1/29, 1/41, how you're adding 12 every time, and it's under 1, so harmonic sequence. We don't really get into harmonic sequences that often. I just wanted to tell you about them. Fibonacci comes up every once in a while. Arithmetic, you're adding the same thing every time. Geometric, you're multiplying by the same thing every time. Hope this was of help to you, and we'll get more of the formulas next time.